You're listening to Two Beers Until Phronesis, a podcast where we discuss the ideas of philosophy, ethics, religion, history, and culture. Alongside regular guests and friends, we discuss some of life's big questions over a few beers. Enjoy. Right. Are we ready then?
Yeah, go on then.
What was that?
Yeah, what was that?
Nothing.
You in a car up?
Are you driving?
Yeah.
Podcasting while driving?
Oh, shit.
Fucking on to you.
No.
Okay. We're going to try some amazing experimental podcasting here where we don't know what the fuck we're talking about the entire time.
You say that like it's not happened before.
This is where it happens to the greatest of degrees, because we're going to talk about quantum immortality, which is going to involve quantum mechanics, many worlds theory, and lots of other things that we don't actually understand because
We're not physicists.
we're not physicists or scientists of any kind. In fact, it's almost like we're the exact opposite because we're all philosophy graduates. So
There you go. I was not on the Sciences Barnacle event at Cardiff. I was so sad.
well, you can redeem that right now if you can explain to us how quantum mechanics works.
Yeah, based on the fact that you got denied or didn't get involved in a science event at uni, you're still more qualified than me and Connor to talk about quantum mechanics.
Do you know what? I think that's right.
Oh, no. Okay. A very, very small level, beyond microscopic, beyond everything, where nothing makes sense. Quantum mechanics is just a theory brought in to basically describe all these chaotic events that happen at a really small level that nobody understood. And it doesn't work with theory of relativity either. It's theory of relativity, everything's very set. This is the maths, everything works. Quantum theory is like, yeah, it's all chaos. We don't know what's going on. On the smallest level, you have particles, not particles, but whatever they are, being created and eliminated like within a nanosecond of each other constantly, and things moving around randomly for no reason a little bit on that level. And you have these quantum particles behaving in strange ways, behaving like two things at once, basically, until you observe them, and then they become one thing. It's called superposition. It's like light. Light is acts like a wavelength and a particle at the same time, they discovered. And when you observe these quantum level particles, it collapses into one thing, either a wavelength or a particle. And you're like, I thought it was behaving like both. It's like, well, not anymore. We've looked at it, and now it's just the one thing. Now it's behaving like the one thing. And it's like, that doesn't make sense.
So it's like at a subatomic level, it's like being in the dark or being blind and bouncing a tennis ball at a larger ball to see how far away that larger ball is.
Right.
But every time you throw the ball, so if it bounces back fast, you know that the big ball was very close. If it takes a while to come back to you, you know the ball is further away. So the problem with that is every time you hit that big ball, the big ball moves. That was one of the examples I've seen. Probably not a particularly good example. To be honest, yeah, it takes years to actually comprehensively learn any of this stuff.
Yeah, the fundamental thing, though, is things start behaving differently when you actually observe them.
Yeah.
And when you're not observing them.
Observing an object will affect it in such a way that things change literally by observing them.
Yeah, merely the act of observing them.
Yeah. So that relates to obviously like Schrodinger's cat and the double slit experiment and all those things that people might have heard of. Just as a side note, actually, I did record a load of stuff, probably about 3 hours with Nye, where Nye explains quantum mechanics. So maybe we're off the hook. If that ever actually sees the light of day, that might absolve any of this, because we can just say, go and take a look at that. So
that's perfect.
If we ever finish that, then you should look at that. But for the meantime, I think we can just sort of do half-assed explanations.
I simultaneously know and don't know what I'm talking about until I say it. Then you realise, he doesn't know. But until that moment, I did know and I also didn't know at the same time. Yeah, and it's easy to explain with the Schrodinger's cat, I think.
Yeah, that's probably the next best thing.
It illustrates it anyway, because I was trying to explain it, avoiding using it basically these particles exist in both forms to observe them. So what if you had, a box with a cat in it, and in the box with the cat is a trap, and the trap is triggered when the sensor detects whether this particular quantum particle is either a wavelength or something else. But the thing is, until you actually look at that wavelength or particle, whatever, it's not one or the other. So the trap isn't working yet. So yeah, only when you open the box will you see that the cat's dead or alive. But until you open that box, it's dead and alive at the same time.
Yeah, isn't something like the cat's in the box with a vial of poison or something? There's a 50-50 chance of the cat either eats the poison or it doesn't eat the poison. So until you open the box and observe it, the cat is both dead and alive.
Well, it's not necessarily that the cat's going to eat it, because that wouldn't be up to a quantum particle then. It's literally like the trap is triggered by a sensor which detects a quantum particle.
Okay.
Yeah, it's not just it could have eaten a bit of shit in the box.
Yeah, because that's not quantum anymore. It's better to imagine it as a bit of poison with a hammer above it that gets dropped if the right particle gets detected, and then the hammer smashes the poison and it poisons the cat.
Yeah.
So how do we define a quantum event from a regular event?
I think it's by the nature of the randomity. So it's not just like.
So it doesn't relate to the cat's hunger levels or anything like that.
No. So it's not determined by the environment.
Because that's
yeah, that makes sense.
Because quantum randomness only affects the really small stuff. When you get big enough, it's so small of a difference that it's negligible.
Is this like Heisenberg's uncertainty principle? So at a subatomic level, things are essentially random?
Yeah, basically.
Yeah, Copenhagen.
But when things are big enough, like it's not a big enough of a force or anything like that to make any difference to anything. Because the fundamental forces are stronger than anything that's random on that level, I think. Maybe.
So basically, everything in the real world, so to speak, is deterministic. So it cause and effect.
It gets down to the quantum level. But maybe the butterfly effect means that these quantum fluctuations do have a big effect in the long run.
I think I remember reading this as one of the sort of theoretical arguments against absolute determinism, hard determinism.
I remember this.
Yeah. But I'm not sure if that's... it kind of brings on to a wider point, because I think we would have benefited from probably knowing a lot of this shit, because this is really where philosophy is in like modern debates and things. And I think there's too much of a contention between STEM fields and the kind of stuff we did, and there's actually not enough dialogue.
Unify the theories.
Yeah, because a lot of scientists just think philosophy is an absolute waste of time, or they think that all philosophical questions can be essentially solved by science, which is ridiculous. But alternatively, you have a lot of philosophy students who are just like completely ignorant of science, which is, I find, bizarre, because they both more or less came out of the Enlightenment.
They're so dependent on each other, I think.
Yeah, well, they're both part of the same project. They're both part of the same movement, historically speaking.
Yeah.
In fact, they were completely intertwined in the ancient Greek era.
Yeah, they were one and the same. There was no scientists, it was just philosophers. Did everything, right?
Yeah. It's like natural philosophers and things, yeah.
Yeah, I feel like the scientists will benefit a lot by being able to ask the philosophical questions on their discoveries.
In the opening of one of Stephen Hawking's books, he actually says that science has picked up the mantle of philosophy. And I think I might have mentioned this in a previous podcast, but that sentence just makes absolutely no sense.
I remember saying that.
It's apples and oranges. It's totally different conversations. The fact that he thinks that science can solve any philosophical questions, maybe at the metaphysical level, perhaps, but you still have to have those philosophical parameters to determine what you're actually talking about.
Yeah.
Just to say, okay, we're doing metaphysics here as opposed to physics, or we're talking about realism versus anti-realism, things like that. You need to frame the conversation first, and then the method of science comes in. Like, the method of science can't frame the conversation because it can't step outside of itself by definition. Philosophy almost tells you why science is valuable, because beyond science itself, the actual practice of science, you have philosophers saying, oh, here's why empiricism is a good idea. Here's why empirical evidence is valuable. And then you do the science afterwards. The science is like step 5 almost, and philosophy.
Yeah, where would they be without philosophy in the first place?
But yeah, but there are a lot of philosophers who just don't give a shit about science, and I think that's really frustrating equally. So yeah, that was just my little rant.
Yeah, I think I remember like the first couple of weeks of my first year of uni, I was talking to people, and one of them clearly didn't really get social environments, and I was like, "Oh, I study philosophy," and then he just blurts out, "Oh, I hate philosophy." They're all arrogant.
He's not wrong.
He's not wrong.
He was doing science as well. And then it turns out, I asked him, I was like, well, what's your experience with philosophy? And he'd only read Aristotle ever. It was the only one he knew about.
That
explains it all.
I'm just like, well, that's just one philosopher. And you immediately just hate all of philosophy because of one guy you didn't like reading.
Well, he probably read it because it's the precursor of science, because it's the sort of proto-science. It's probably where you can track the genealogy of science back to. Which I think is really interesting. But yeah, to a modern scientist, I guess a lot of what Aristotle says metaphysically is fucking bonkers and completely not right. I don't know. I think that's just an ignorance of not having read a lot of philosophy or seen the value of it.
I'm just like, you do realize I study this, right?
Yeah, it's really common though. I get that all the time. I get that experience all the time. I get people.
Yeah, I never bring it up.
You get told that philosophy is either useless or pointless.
Yeah, a lot of the times it's, what did you do at uni? I did philosophy. We can do with that then. Well, interesting.
Yeah.
Does it have to be anything more than that? Yeah, literally.
For a start, there is a lot you can do, and
absolutely.
Also, like, why are you saying that? Like, it's very strange to say to someone at like a party.
Or maybe, Al, there is an alternate world in which you did study something vocational, which brings us on very nicely to the many worlds theory.
Wait. First, I wanted to finish the quantum point.
Just bring us back
we only just established quantum stuff. Oh god, what were we even talking about? The cat.
I don't know. How many times can I change the subject?
Yeah, let's just keep changing it.
It's good. We need this.
Part of the evidence, maybe, of quantum physics is that you ask yourself, if all of the traditional physics is right, then you should expect there should be equilibrium in the universe. But if you look out there in the galaxies around us and all that, not everything's equal or symmetrical at all. In fact, it's all quite random, seemingly, of what's happening out there. Everything's distributed randomly. You have superclusters of galaxies and you have voids. It's like, well, surely if the Big Bang happened and exploded all matter, it'd be, quite samey, basically. And you can partly explain that way by saying, oh, well, the universe is so big that if you zoomed out far enough, everything would look symmetrical and equal. But I don't know about that one, because another reason is that when the universe was, right at the start of the Big Bang, as small as a singularity, everything would have been on the quantum level, meaning the quantum randomness would have actually had a big effect on it. And the distribution of matter would have been following the chaos of that quantum level. So when it did explode, it was all in a random position thanks to the chaos at that level already. So then everything expanded out, and now we see the lack of symmetry and how everything's all distributed randomly, seemingly, nowadays in the universe. Because those split seconds of chaos right before it expanded bigger than the quantum level.
So is there a theory that's directly a contradiction to quantum physics and quantum mechanics? Is there?
I don't think so. Quantum physics is just explaining why everything is, and it's why it's the leading part of physics.
Am I right in thinking it's not really explaining it, but explaining it by not explaining it?
Yeah.
In some kind of weird cyclical way. So it's more of a labeling.
Yeah, it's the new theory because they realized, theories of relativity can't explain this.
Right.
Let's come up with some new solutions, theoretical solutions. Because, before theory of relativity was around, they proved it in maths and theory first. And then later on, they started discovering it all and confirming it. And it's the same with quantum. We haven't confirmed it all yet, but our past ideas are outdated because we're seeing things that aren't in line. Because, well, maybe we're describing it as chaos at the moment, merely because we don't understand it.
Right, okay, yeah, I understand that.
And if we did have a full picture, then we would actually be able to explain it. It wouldn't look random. But at the moment, they're like, it's literally just random.
So it's a possibility that we're explaining a part of it without realizing the bigger picture.
Yeah, well, we're explaining the effects.
Okay, yeah.
Rather than what's behind it, I think.
Right.
many worlds theory?
Yeah.
Yes.
Let's
Yeah,
talk about that.
let's go with that. Okay, so quantum immortality, which we will get onto at some point, it rests on the idea that there are many worlds. I'll probably mess up and say possible worlds at some point or alternate universes, but every time I say it, I mean many worlds in the sense that there are infinite possibilities and infinite universes of certain scenarios happening. So there is a possible universe or a possible world in which in the next 2 minutes I will spontaneously combust. Fingers crossed, this is the universe in which that doesn't happen.
I hope it is the universe where it does happen.
Maybe I do wish it does happen, so I don't have to explain this. Maybe. But yeah, so if something can happen, it will happen, basically, but just not necessarily in this world. It will be in another possible world. So every second, there is kind of a coin flip into whether you're living or dying.
Yeah, like, and if it was the Schrodinger's cat, then it's a coin flip of whether the cat lives or dies. But in another universe, when we open the box and it's dead, there is another possible universe where it is alive still.
So you're about to decide whether to give this video a like. No, you're about to decide whether to jump off a cliff. So at the moment you make the decision, it splits off and two worlds are created. One where you jump and the other where you walk away and don't do it. But every decision you make, that happens. So the universe is split into infinite possibilities.
Yeah, every junction, if you like, or every potential fork in the road, it splits infinitely.
And each world is oblivious to the other and just continues. So there are near infinite amount of different worlds.
Yeah, it helps account for the randomness in quantum, because instead of it being random, they're just like, I don't know why this happened rather than the other thing, and there's no reason for that happening. It did happen.
Yeah, well, the other thing also happened as well. Yeah.
It's all equally real. It's just yours locked into one particular timeline. So
yeah, if there are many worlds, infinite eventualities or possibilities, technically speaking, in terms of the convention of how that works, we may be immortal on a quantum level. So if there's a junction in which I think Carl touched on a minute ago, we stood upon a cliff. There is a possible world in which you jump off the cliff, and there is an infinite possible world in which you don't jump off the cliff. And every time you're faced with a situation that could result in death or could not result in death, depending on which way the coin lands, a possible world splits off. So at every point in your life where there is a potential encounter with death, there is there's infinite worlds in which the result of that is not death, meaning that based on that, you are immortal because in every situation there is a possibility you'll survive, and that can go on indefinitely. Have I lost everybody yet?
I think that made the most sense of everything so far.
That doesn't put it very high, I'll be honest, but
yeah. So there's this thought experiment which probably wouldn't work in real life because it relies on kind of like really idealized, contrived circumstances that is probably impossible to create. And also, it's probably worth noting that this is controversial even within the community that believes in many worlds theory. So it's like Schrodinger's cat, but not only are you the observer, but you're the test subject. So you're inside this box, and there is a quantum, so completely random variable that there's going to be a 50% chance that you die every 3 seconds. Every 3 seconds, this timer will either click or it will set off a giant nuke in your face and you'll die. So you're definitely going to die.
It's certain to kill you.
Yeah,
definitely going to die straight away.
So it's a binary dichotomy between A and B. If you sat there for 3 seconds and you hear a click, another 3 seconds, you hear a click, another 3 seconds, you hear a click. Each time it exponentially gets so unlikely that you could have survived this long, to the point where if you're hours down the line and you still haven't died, at that point, you must be immortal.
Yeah, so to put it in terms of numbers, every 3 seconds, this coin flip occurs. So after 300 seconds, the coin flip will have happened 100 times. And after that, if you still haven't blown up and died, there is I think it's 800 quintillionth % of a chance that it is just chance you're still alive, which essentially may as well mean impossible.
Mm-hmm. Although it is still possible.
Yeah.
You just assume what you think to yourself, well, I must be immortal. Because, the chances of me being immortal aren't that much further away from me surviving this long.
Right.
Is that right?
But based on the fact that you've set up this experiment correctly, which admittedly is near impossible, but...
So if you survive all iterations of the experiment, it's like you live by necessity at that point.
Right.
So there is still a world where it's been literally days you sat there and you just think to yourself, I guess I'm immortal. Then the next click kills you.
Well, but yeah, I suppose so.
That'd be funny.
That is an excellent point. How long would it have to be left before you decided, you know what, I'm quantumly immortal. I've done it. I'm a genius. Because the whole time there is still a chance. Yeah, I get that now. So do you have to exist for the rest of, existence in the box for it to be a solid experiment? So are we working on the assumption that the numbers look so impossible that it must be impossible?
Yeah.
Yes, it's to illustrate the point, or an argument for it.
Yeah.
If this happened, then you would probably assume that that's the case.
Okay.
It's in favor of it. It's probably worth noting that each time there's a click, there's obviously an alternate world where you explode. It's just use of...
Right.
This is... You live in the world where that never happens, but the other worlds are being created at the same time. It's just you don't live in them.
Yeah, each time there's a click, there's a new branch of a universe where you did die. Yeah.
Okay, so I found here there's 3 sort of parameters, if you like, for the experiment to work properly. So if you set it up with these 3 parameters, then you'll have a good chance of figuring out whether or not you're quantumly immortal. I do apologize, I'm taking this straight from the wiki. But the 3 parameters are: the random number generator must be quantum, not deterministic, so the experimenter enters a state of superposition of being dead and alive. So this is kind of the whole death being a binary thing. So it's A or B.
Yeah.
That is it. There's no in between. There's no, it's blown up a bit of your shoulder and you're nearly dead. You're dead. That's it.
Yeah, it can't be progressive. It can't be something that slowly happens to you. It has to be literally mathematically A or B, which is why this can't be continued into the real world, because even with things like not stepping out into the pavement so you get hit by a car, even those things aren't necessarily A or B. They're more deterministic. They're not like mathematically random.
No, right.
Or something.
Second parameter, which is going to need some unpacking, I think. The experimenter must be rendered dead or at least unconscious on a timescale shorter than that on which they can become aware of the outcome of the quantum measurement. So I think we touched upon this earlier briefly when we talked about death being dragged out. So being at the point where like half of your body's been blown up by the nuke and you're then starting to become aware that yours is the timeline in which you'll die, which messes up the whole experiment, because it's supposed to be the case that you that's going to die doesn't know they're going to die. So you are immortal in the sense that a version of you exists. The ones of you that die don't know they die.
It's instant.
Right.
They just don't exist anymore.
Exactly. If you start to become aware that your existence is ending, then you're also aware that you're not quantumly immortal, which ruins the experiment entirely.
It's that weird, like, experiential part of this, like the phenomenological. There's like what's a weird phenomenology circular stuff going on. Yeah.
One little thing I wanted to go on. So the progressive death and how it doesn't apply here. So say if you were dying from a terminal illness, and then if you're arguing via quantum, you'd be like, well, maybe you could be immortal because every second that passes, you could succumb to your illness or whatever, or every day. But then each day is a coin flip of whether this is going to be the day where you die. Then potentially it can carry on infinitely, that you keep succeeding the coin flip, that you don't die from your illness every day. Why is that wrong? Well, because the non-quantum level with that, the cause of your death are determined by the bigger deterministic things.
That's it. In that case, it's not a quantum number generator, is it?
You dying every day isn't reliant on some random quantum thing on the quantum level. It's reliant on your body being shutting down and on a big level rather than the quantum level. So that's why it doesn't apply, because the quantum decider probably would have happened ages and ages ago already. And now that you're declining, you're in the universe where you are going to die of this illness as soon as you contracted it. There's not a chance that you'll keep living with it forever, because your body's going to follow the determined course of degradation.
Right. That kind of brings us on to the final parameter of the experiment. It's quite a simple one. We've already unpacked it quite a bit. The experiment must be virtually certain to kill the experimenter and not merely injure him or her. That's self-explanatory, because if it doesn't kill you, then that's, you can survive not being killed because you haven't been killed. So it doesn't really work as part of the experiment. So
I love quantum physics.
Yeah, it's really easy to explain and understand, isn't it? Especially if you haven't fucking studied it.
Yeah. I'm sure it's no fun if you actually study it. It's like,
Constantly name drop the word quantum. It doesn't really... They do that in things like Ant-Man, don't they?
It's got nothing to do with what they're doing on screen.
Because he goes really small.
Doesn't even make sense, Ant-Man. They shrink the distance between their atoms, which is actually huge. An electron around an atom, like the distances between them, like the nucleus of it is like a fly in the middle of a cathedral, and like that's the radius around it that the electron flies around. And then obviously then you have other cathedrals next to each other, but the actual atom itself is the fly inside the cathedral, and that's the distance between atoms. So then Ant-Man is like, well, if you shrunk all the distances, so you're still you, but you're just really small. But then he's like, he shrinks so far down that he goes to the quantum level, but the quantum level is smaller than the atoms that he's made out of. So it doesn't even make sense how he can make his atoms. He can shrink them down smaller than they are, like down to that level. Because his whole mechanic is that he's not actually shrinking the atoms, he's shrinking the distances. But then he shrinks the distances so small that he's now smaller than the actual atoms, like an atom itself. Well, the distances between atoms aren't that big that you can shrink yourself smaller than they are. Well, quantum level is smaller than the atoms, right?
Yeah.
He's made out of atoms.
Yeah.
So to be small, he's not actually making the atoms in him smaller. He's just making the distances between them smaller.
But that doesn't make him smaller than an atom.
But no, because, how can you fit like however many atoms there are inside Ant-Man in the smaller space of an atom?
How do we go to debunking Marvel films?
I think that could serve as a nice little...
Well, that's a mini experimental episode. That's all right, isn't it?
Yeah, it's like a little introduction.
Yeah.
And now we'll go on to Nye explaining everything we got wrong. So you, the viewer, can actually know what's happening. Take it away.
Yeah, you can use that.
You can actually learn about quantum mechanics.
It could be like a little listening exercise. You can listen to Nye, understand how it actually works, and pick out where we've got it wrong.
Yeah.
Engage the listener. That's what it's all about.
Nice.
Can you correct the idiots?
I feel like my brain is one-dimensional at the moment. Jesus.
The wonders of conversation. It's like pub talk, isn't it? This is what pub talk's like. Yeah, there's a possible world a quantum world where we did just talk about nothing but quantum. The whole
we got it all right.
Never diverged. Yeah. There you go.
We were intellectually immortal.
Does anyone know about string theory? Because I don't.
I heard it in the Big Bang Theory once or twice.
You guys seen Quantum of Solace?
Did I just make sense?
No.